Example 4a, find the exact value of sine 75 degrees. Okay, sine 75. We've never been able to do that before, but now we can if we use some of the numbers in the chart. Okay, pretty quickly you can see that sine 75 would equal sine 45 plus 30. You could switch it around, say 30 plus 45, 45 plus 30. Sometimes there's more than one way of doing it, but whatever. Sine 45 degrees plus 30, that's the same thing as sine 75. And so, if you don't know this formula, look back at it. It's a sine sum. Sine sum means we're going to have sine, cosine, plus cosine, sine. There's this formula right there. Okay? So maybe you don't have to memorize it, but it helps, I think. We have sine, cosine, plus cosine, sine. Sine, cosine, plus cosine, sine. Okay? And just use the chart. Sine 45, square root of 2 over 2. Cosine 30, square root of 3 over 2. Cosine 45, square root of 2 over 2. Sine 30 is 1/2. I don't know if you remember the last time we did this, the last example, it pretty much looks exactly the same. The numbers are almost always going to be close. Okay? When we clean up this fraction, we're going to square root of 6 plus square root of 2 over 4. Sine 75 degrees equals square root of 6 plus square root of 2 over 4. And you might be saying, well, last time we did cosine 15, and it was the same thing, but of course they are, because remember cofunctions? Those two are cofunctions. Cosine 15, sine 75, those are the same thing. So of course we got the same answer. Example 4b is going to be harder. Tangent is just hard, okay? So, 7 pi over 12, where's that come from? Again, look at your angles in radians and get a common denominator. So that's 2 pi over 12. That's 3 pi over 12. 4 pi over 12. 6 pi over 12. You can tell we can get 7 pi over 12 by adding 3 pi over 12 plus 4 pi over 12. Okay? So that's what we're going to go through. Tangent 7 pi over 12 is going to equal tangent pi over 4 plus pi over 3. These are the reduced versions. Pi over 4 plus pi over 3 would happen to be 7 pi over 12. So, your pattern for a tangent sum, says tangent of the first plus tangent of the second over 1 minus tangent of the first one times tangent of the second one. Okay? So tangent pi over 4, got to look at the chart. Tangent pi over 4 is 1. Sine over cosine. Tangent pi over 3, square root of 3 over 2 over 1/2 is going to be square root of 3. So tangent pi over 4 is 1. Tangent pi over 3 is square root of 3. So looking at what we have 1 plus the square root of 3 over 1 minus 1 times the square root. Or 1 plus square root of 3 over 1 minus square root of 3. And I would love it if we were able to stop there, but we should know from algebra class that we're not allowed to leave a square root on the bottom. Okay? And so for me, the hard part is the algebra here. We have to rationalize the denominator, which means we're going to multiply by 1 plus square root of 3 over 1 plus square root. Okay. So foiling here, I would see 1 plus square root of 3 plus square root of 3 plus 3. And on the bottom, there's a shortcut, but the first time anyway, I won't use the shortcut. When I FOIL this, I'm going to have 1 plus square root of 3 minus square root of 3 minus 3. So the shortcut is that square root of 3 cancels out. Okay? So I'm looking at 4 plus 2 square root of 3 over negative 2. And I'm not really reduced here. I'm not allowed to leave that negative on the bottom, but I can divide everything by 2 and divide everything by negative 2. If you clean that up, if you simplify, 4 divided by negative 2 is negative 2, and 2 rad 3 over negative 2 is minus square root of 3. So there I have tangent 7 pi over 12 equals negative 2 minus square root of 3. Exactly.